Hello everyone again and welcome to Machine Learning Tips. So today we will be looking at confidence intervals, p-values and the t-test. Why this is very common is because we use this a lot, especially if we build multiple models and we want to just compare them and see which one is significantly different from the other one and why should we choose that model over the other. So first of all, start with the confidence interval. Confidence interval is a statistical measure which is used to measure a range of or find a range of possible values for a population parameter. That population parameter here could be the mean. We have seen the mean based on some sample. Now, I did mention here that yesterday that size sample is just like a subset of a population. So if we build a model, say for example, we just consider 200 different samples for a particular evaluation metric, we are going to see that, or maybe for a population, if we are carrying out a census and then we pick a sample from that population, we might want to calculate the mean to see, like, if we were the height of people in a particular country or a sub-region, we want to see, where does the height of people within that country fall. That is when we use the confidence interval. So for example, we can want to compare to say maybe 95% confident that the true mean lies between A and B. That A and B here will be between what? Those two, between two values. So we are going to see how we calculate confidence interval, which is like looking at will it be less than or equals to or greater than or equals to this A and B. Confidence intervals are used a lot to express uncertainty around a sample estimate, and that sample estimate here is like what? The mean. So the formula for the confidence interval is we take the mean plus or minus the z-score divided by the multiplied by the standard deviation divided by what? The square root of n here. So the mean here, x bar here, is what we call the sample mean, meaning that if you sample from a population, you like the height of people in a country, you want to know where do this height value, what will be the minimum and maximum value where the height of people in this particular country can be measured. And then the z-score, we are looking at the 95% confidence interval. The z-score value for this will be 1.6. We are going to see how we calculate this when we are doing some of those labs that I did mention every weekend. We have seen how to calculate the standard deviation. A sample here is what? The total number of people that I'm sampling from that entire population. So for example, if we have a sample mean of 70, standard deviation of 10, and then we pick a sample of 100, maybe 100 students in a class to look at the height. So the confidence interval now becomes that mean plus or minus, since we are looking at the 95% confidence interval, the z value here will be what? 1.6 multiplied by, we are taking the standard deviation divided by what? The square root of n. So if we do this, we will see that the sample, the mean of that population, because we are now inferring it to the population, we can see that the mean is less than or equals to 71.96, but greater than what? Greater than 0. Greater than 68.04. So the interpretation here is that the true mean is likely to be in between what? This range of values. So the next thing we'll be looking at is what? P-values. For those of you who have taken some base classes in statistics, p-values are being used for mostly what we call hypothesis testing. So that p-value is just the probability that you are going to observe a result or more extreme result, given that the null hypothesis is what? True. This probability, we are going to see how to calculate it. And then when we talk about observing a result, that result could be when we are comparing the means of two groups, or we are looking to compare the mean of a sample if we already know the population mean. So the null hypothesis here, we are going to see it, the definition of this null hypothesis as we move on into this lesson. So a low p-value here, meaning that a p-value which that probability, remember we are talking about the probability. We did look at probability. Probability of some event is always less than or equals to 1, but greater than or equals to what? 0. Let's note that probability can never be more than 1. So when we calculate that p-value, since it's a probability, if the value is less than 0.05, and then there is strong evidence against that null hypothesis, then we are going to see what conclusion we can get from here, which is most likely a rare effect. And then when that p-value is a higher value method, meaning that it's greater than 0.05, then we are going to draw some conclusion, not statistically significant, which implies it could be due to what? By chance. So p-value thresholds, we see this. So any value which is less than 0.01, we have very strong evidence against that null hypothesis. Any value which is less than 0.05, it is statistically significant, and any value which is greater than 0.05, it is not statistically significant. And what is hypothesis testing in statistics? So hypothesis testing is used a lot in statistics when we are trying to test assumptions about some data. So we use it to determine if an observed effect is statistically significant. That observed effect here could be, are we comparing the means between two groups? Or maybe we were doing our experiments and trying to look at maybe the temperature of a particular group of animals in a particular region will be different from other animals in another region. We can look at the means and then try to compare them. So in that case, the null hypothesis will be that the means are the same, and then the alternative will be what? Will be that the mean of those two groups are different. And then when we calculate that p-value and it is less than 0.01, then we say there is a strong evidence against that null hypothesis, and we are concluding that there is a difference between the means of those two groups. Same if it is less than 0.05. But when it is greater than 0.05, then we do not have any strong evidence against that null hypothesis that the means are different. So the null hypothesis here is always what we call the default assumption. We are saying here that if we are looking to compare the means of two groups, we are saying that no effect or no difference. No effect here simply means that there is no difference between those two means, meaning that those means are equal. Or maybe if we were trying to test the effect of adding for those of you doing mostly this scientific experiment, maybe you are doing an experiment that has to deal with a lab experiment where you're trying to maybe mix chemicals, or maybe adding chlorine to some other chemical element to see whether there is an effect when you add that chlorine or no effect. So you can use that a lot to now test if there was a difference when you added that substance, maybe chlorine to sulfuric acid, and if there was no difference. So an example here, let's go in terms, since we are using machine learning, our example here will be what? If we train two models, let's say model A and model B, and we can try to check if the accuracies of these two models are same. We are going to see how to measure the accuracy. Another way in modeling could be what? A future does not affect the target, meaning that the target variable here is like in the case when we were predicting the prices of houses. So the target variable here was the price, and then the input variable here was what we had, the size of the house. So the question here will be what? When we does the size of a house, does it affect the price of that house? So those are the kind of things we can try to test using this hypothesis testing. So the alternative hypothesis is like the opposite of the null hypothesis. Since in the null hypothesis we are saying that there is no effect, for the alternative we are testing if there is an effect, or what? Or there is a difference. So that is why we are seeing here that, and remember, mu1 here and mu2 here is actually testing what? If they are looking at the means of what? Two groups. So for example, model B is more accurate than what? Model A, if we are trying to compare the accuracies of those models. And then a future significantly impacts the prediction. prediction here will be, maybe we are looking at spam emails, and we are saying that when you add a word like win, you add a word like congratulations, does it have any effect into saying that an email is spam or not? Those are the kind of things we are going to see for hypothesis testing when we move on to machine learning. So in practice, we use hypothesis testing to test if data provides enough evidence to reject that null hypothesis. We already saw what the null hypothesis is. If the p-value is less than 0.05, we will always reject that null hypothesis in support of what? The alternative. If the p-value is greater than 0.05, we are failing to reject that null hypothesis because we don't have enough evidence. So we use what we call the t-test to actually do this hypothesis testing. Now, a t-test in statistics is used to compare the means of two groups given that if the sample is small in size, and also if the population standard deviation is unknown. There are different types of t-tests. We have the one sample t-test, which we are trying to compare a sample mean to a known value. That known value here is, for example, if we have conducted some census and we know that the mean for the height of people in a particular region is known, then we can try to pick a sample from that population and then try to estimate from that sample if there is actually a difference between the mean we obtained from that sample from the population mean of that entire population. Another type of t-test is what we call the two-sample t-test, which is used to compare the mean between two groups. As I did mention here, it could be you are testing a drug where you between a placebo and you're trying to see if there is a difference between some two groups where you are testing that drug with. Also, it could also be applied in machine learning where we are testing the accuracies of two models to see if they are different or not. And then a pair t-test. A pair t-test is used if we are having to compare the means of two groups before versus after. It is mostly used when we know that these groups are same. So we can use a pair test. So most of the times in machine learning, since we are building, if we are using the same data set and then trying to build maybe two models, we always assume that those models are independent. So we are going to use what we call a two-sample t-test. But if we are sure that these models, there's some relationship between them, then in that case, we are going to test maybe we are having a data set which is imbalanced. We are going to see what imbalanced class problems are. And then we balance up that data to make sure the classes are same. And then we train two models, one with the unbalanced data and the other one with the balanced data. And then we can use a pair test to compare the accuracies of those two models because we are using the same data set and using the same model, but trying to use the same data set, but with different samples. So we use this t-test commonly to is mostly used for what? For A/B test, A/B testing. So the formula that we are going to see, especially for the two-sample t-test, is we know the means of those two groups, and then also we are going to be calculating the standard deviation for group 1. We know the sample size for group 1, as well as we know the sample size, the standard deviation for the second group, and then we also know the sample size for the second group. From here, when we calculate that t-test, we are going to see how we compare the score we got from this t-test to the critical value from a table distribution. We are going to see this when we move to the lab sessions. So let's say we have an example where we have two groups. Group A we are having two models where the accuracy of the first one is 6.2%, the sample is 100. Group 2, same sample, but the accuracy is 7.1%. So if we do this calculation, the p-value here will be equal to 0.03. Here if we are comparing the means between these two groups, and we are looking at their accuracies, and then this is statistically significant. So we are simply saying that there is a high chance that group B is likely better than than group A. So in summary for this lesson today, we looked at the confidence intervals to provide a range for estimated values. We also looked at the p-values that can help determine a statistical significance. And then also we looked at the t-test where we can use it to compare means between two groups. Guys, that was it for today's lesson. So tomorrow we are going to be starting machine learning properly, where we are going to start with supervised learning. Thank you so much and see you.